Good evening, everyone. I am your host and instructor, Laney Shaughnessy, and welcome to Spindle TV, your best source for CNC CAD/CAM training videos. Spindle TV is brought to you by Digital Woodcarver, inspiring your creativity and providing you with the tools to create your own unique masterpieces.
Good evening, everyone. Got a late night class tonight from 8 to about 9:30. We're going to do a live Q&A, and we're going to just answer some general questions with regards to the Vectric software and things, and kind of cover some topics based on those questions and answers. We're also going to come in and I want to talk to you guys about the new training schedule for classes and stuff, and get your take and your opinions on it. So let's give everybody a chance to come in, and then we'll go ahead and get rolling. Now, hopefully tonight it's a little bit of a test for me. I'm using a different output ratio. So hopefully we will have still clear quality in the videos, but less buffering, less issues and problems and things. So kind of what I'm hoping for is a little bit of feedback as we go through tonight in the testing and stuff. Let me know what you think, and if you're getting buffering still and all, because I am down to the last little possible thing that I could fix or clean up to make the classes run smoother with less buffering and all. I'm using a different output ratio and stuff, and bit rate, for the film and all. And I want to make sure that this new output and all, I'm not losing too much in quality and clarity in the video. Now, in the preview that I'm watching as we're going through this, looks very clear as far as the camera is concerned, but what we want to get into is when we're actually looking at the actual Vetrix software or anything like that, what the clarity looks like there. So we'll give everybody a chance to get in, and then I'll go over the announcement as to how our new training schedule is going to go for these classes and everything, and then get your feedback on that, and then we're going to do some Q&A. Yep. All right, and Dennis, you don't have to worry about that. Work always comes first, buddy, bro. All right, so give it just a few more minutes, and if you want to, you can go ahead and start typing some questions in there. We can kind of get those lined up and queued up for me, if you'd like. We're going to try some Coca-Cola tonight because I'm out of Dr. Pepper, so we'll see how that gets me through the evening. Oh my goodness, Coca-Cola. Nothing wrong with Coke. Love Coke if they're out there listening. All right, so let's go ahead and kind of get started. I'll repeat myself. I'll repeat myself if I have to, but let's kind of talk about the training schedule. So as far as the training nights and things, night's not going to change. We're either going to be, I think it's going to be Monday evening for the training classes. I believe that, starting off the week, it'd be good. It gives us kind of the whole week to practice, but I want the training classes to be a little bit better experience for you guys. And coming up with 2 classes a night, 2 subjects and everything, you can see kind of their last minute as far as getting the postings up as far as what the class is. I haven't been able to get the schedule up, but the training lessons aren't very fluid. There's a lot of stuff going on and stuff, and And what my goal is I would love to be able to have a finished product that was carved, kind of a detailed outline of it that was carved, and then be able to create the curriculum based on that, so you can actually see the finished product and then how to make that finished product. And what that will do is it will give me a chance to thoroughly test everything, these classes and these lessons that I'm providing to you, but also it will allow me to do more interesting products instead of the same old basic kind of things. We can kind of get more involved. Your all's skills, depending on the different levels that you're at, beginner, intermediate, advanced, you're growing. You're growing each day, and you are evolving. And I need to evolve with you. I can't just be just being kind of the rinse and repeats type of stuff. I want to be able to do some cool things where we're actually not just cutting signs and stuff. Maybe we're building something, whether it be a table or a chair or just anything, really. And so here's what my thought is, and I want your feedback on it. So my thought is this. The classes will be on Monday evenings. And we'll keep the 7 to 9 because people work and stuff like that. We'll keep the 7 to 9. But we're going to just do the one class a week. What that will do, and if it's a 2-part class, if it's a big project or something, then we will split it up and we'll do a Monday and Wednesday. But for the most part, it's going to be a Monday class. And what that allows me to do is that gives me Tuesday, Wednesday, Thursday, Friday to develop the class course, to actually carve the part, work out any kinks or obstacles that I might come across, and develop a nice little plan, have the finished file all ready to go to share in the Facebook group and stuff like that, and then of course present that project in the class on that Monday. So I'm going to be Tuesday, every day I'm working, answering calls and stuff with you guys and everything, and so that last minute rush of trying to come up with a class idea and then just throw it out there is, it's a little tough, and it's not a very nice class. We can be more direct and more instructional, easier to follow videos and things if we have the plan, the project, and we demonstrate how to execute that plan. It'll make it more structured, more organized, and a lot cleaner. Better tutorials. I want to improve the classes. And the last minute classes throwing up and just kind of just whatever, sticks go, it's not helping you. It's not helping you grow as carvers. And it's kind of making the classes stagnant. They're not doing anything. Also, like tonight, we're having a Q&A. Honestly, because I want to get your questions and answers and help answer some of those questions I haven't been able to get to during the week and stuff. But at the same time, I didn't have a subject for tonight. So the only subject I could come up with is a Q&A. I believe if we would get better quality, it's not like we're losing anything. If we cut the classes back to once a week, we will be able to get better quality classes once a week. Better quality projects, better quality instruction, training, lessons. And so therefore it would be more beneficial to you. And as a side from the live class, during that same week, there's going to be a very short, to the point, pre-recorded course. How to use the extend tool, how to split a model, how to create a vector, whatever that little subject is, that direct to the point topic is, that's going to be a pre-recorded class, not live, and that video is going to be released. And then our live event, these classes here are going to be Mondays, and they're going to be in-depth classes covering the project in the tutorial that we have come up with for that week. And I'm going to be looking to you guys and girls for ideas in the Facebook group. I'm going to be looking to you to spit out some project ideas, things you would like to see made and all. I've got a really cool one that I want to make, a rocking horse for kids. You know, we got holidays coming up. You know, this year's flying by fast. You know, we've got rocking horses, you know, Harley Davidson rocking horse, a regular horse rocking horse, things like that, you know, those projects. But those take time to lay out. They take time to actually carve, to test, to make sure all the parts and everything fit and everything. And that will give me the week to perfect the project, be able to show you a finished piece. You know, at the beginning of the class, here's what we're making, and then go into the class. And if it's a long class, I want to keep them short. You know, I want to keep them down hour and a half. But if they run long, then we will have a part 2, and we will finish that up in the same week. We will have that Wednesday class, and we will finish up part 2 of the same project if we have to. You know, if it's going to be one of those where there's a lot of information, a lot of detail to it and things. So that's it. I don't need to. You get the idea. You get the point. So I'd like your feedback on that in the comment section and everything, what you think about that structure. And I'd like to start to implement that right away and everything. And all. All right. So in the meantime, now let's go ahead and let's talk about Q&A. Our questions and answers and stuff. And Howard, starting us off, let's see here. Howard starting us off with, it's not a newbie question, it's actually a very good question. The molding toolpath, can't get it to work. You watch the videos, but have a brain fart. Trying to cut the vector or make the angles doesn't work for you either. That is a good question. So let's switch over off of me now and into the Vetrix software, and we're going to start off with that question. So keep the questions coming. Peter, yours is going to be next. We're going to kind of go down the line, but let's talk about the molding toolpath for a moment. So let's go ahead and switch over to our Vetrix software and take a look here. All right, now this is where the 480p stream that I'm putting out is going to definitely make a difference as far as rendering and everything, but I don't know what the clarity looks like of the screen, if it's blurry or if it's clear and things as far as the Vectric software. I'm hoping that it's somewhat clear to where you can see things and all. But again, this is just a test. I'm not saying that I'm switching to this 480p type format, but by reducing down the bit rate and everything, it's going to allow your computers on your end, my upload rate, it's going to allow your download rate and all flow smoother and not buffer as much. So we'll see how it goes, but I think it's going to sacrifice a little bit of the clarity or the quality on the icons and stuff over here. Not sure. I can't. What I see looks fairly clear, but I'm not seeing the same thing you're seeing. I do see a little bit of distortion in the menus and things, but let's I'll make sure when I'm pointing to something, I'll describe what I'm pointing to in case you can't see it clearly, because I can't change the bit rate in the middle of a stream. All right. So let's go ahead and talk about this. When you're creating a molding toolpath, whether you are following a path, whether it be a rectangle, whether it be a line, whether it be an arc, whatever the path may be, we have to have two things. One, we have to have the path that we're following, whether it's a straight line, a rectangle border, an oval border, an arc. We have to have that path. We also have to have the actual profile that we want to follow that path. for the molding that we're going to be creating. And so therefore, the best way for me when I'm creating a molding is a molding profile, is I start off with the rectangle tool, if that's the general shape of my molding. And by doing that, one of the things that I'm looking at is on my width and height of my, my profile. My width of that rectangle that I'm going to draw is going to be the width of that piece of molding. So if I have a 1-inch frame, like a picture frame, and it's got a 1-inch kind of border, then my rectangle is going to be 1 inch wide. My height, if I'm working with 3/4 inch material, I can either work with the full 3/4 inch height, or I usually go around a 1/2 inch or a 0.625, and I leave a little bit of a 1/4 inch of meat kind of on the bottom side of that rectangle there when I create the profile. But whatever the shape is, or the border is, so it needs to be. If you were making a piece of trim, right, like a straight piece of trim for a dresser or for the floor of your home or whatever the case may be, then, and let's say that trim is 3.5 inches wide, right, by however long, then your rectangle's width is going to be, 3.5 inches. So we're going to do a 1 inch by 5/8 profile. Now, when you're creating the profile, you only use the left, top, and right side of your rectangle. You do not use the bottom, and therefore we have to delete that bottom line. So if we go into node editing, we can put our mouse on that line and we can right click, and that line is called a span. The point between two nodes is a span. So if we delete that span, it will remove it, and that will give us our 3 sides for our profile. From here, you can start to shape out your profile. So let's say that I want to bring this side down about halfway, on its line, on its span, bring it down about halfway, and then up here on this line coming down, I want to turn it into a Bezier curve so I can kind of curve it a little bit, and I'll bring this curve down a little bit so there's a nice sweep here, and I'm going to bring this one kind of dramatically up a little bit so we have that nice arch. And now I can come in and let's say that I want a couple of beads in my profile, maybe a step down to a bead or something. I'm going to, wherever I want that bead to be and however big I want it to be, I'm going to create that, whatever it is. And let's go with a 1/8 inch, oops, not 125 inch, 1/8 inch bead. And from that bead, when that arc comes up, and it goes into the bead, at the bottom of the bead I'd like it to have a straight step down and then straight across over down to this arc. So I'm going to take my line tool, and at the bottom of this point here, I'm going to probably step away just a little bit, not much, and I'm going to come down. This is about, let's go about 0.12, and I'm going to come over, and I want to come over 90 degrees, and I'm going to snap here. Okay, and then I'm going to space bar to finish. Now I can come in with my scissors and I can start to trim some things away. So I'm going to have a bead here, and at the bead I actually want to change that a little bit. I'm going to take this guy here, and I want that bead at the bottom of the bead, I want it to step straight down. So I'm actually going to kind of bring it up. Let's use my control key and come over. And now I'm going to go back to my scissor tool, and I'm going to trim away this line here, this line here and that line there. So I've got this kind of beaded profile here with a nice little arch, and that will be my shape. Now I have to look at my overall height because I've actually raised that 5/8 inch rectangle up. Now I have this bead coming up, so that actually changes my overall height. So if I look, now I'm at 0.684. Well, I still want to maintain my 1 inch, so I'm going to unlink the XY, and I'm actually going to adjust my size. I want this full size of this profile to be 1/8 of an inch, 0.625. So I'm going to rescale it down. Okay. Now that I have that, I have my path, whichever path I want to use. We're going to go over to the molding tool path, and we'll start off with the line. So if I select my profile or my line first, then my profile last, okay, I can then calculate. I'm going to use an 1/8 inch ball nose bit for this. I want it's not going to be rounded or square because it's not corner, so it's going to be nice and sharp, so I don't need to check off create sharp corners, and I can calculate that tool path. So therefore, when I carve it, let's kind of come in. Be a little hard to see. Now, notice in this profile here, we'll cut it out in a moment. I've got a flat spot up here where my bead and things are, where it kind of flattens off and everything. So let's see if I can turn it this way. So you can kind of see I've got that bead coming up, but it kind of flattens off here on the side versus coming around and down. So let's look at where my model position is. All right, so the top of my board is flat, so I'm ending up with a flat spot. So I'm going to add actually a little bit of meat above this and recalculate that tool path, so I get that nice radius, that nice curve over and all. And let's reset that preview and preview it again. Okay, still getting that flat spot. So let me make sure that I don't have anything checked off in here. Let's see, I don't want to my radius. Where's my bit at? Let's look at my bit. I'm going to step that bit down a little bit. As soon as I find it. There we go. Calculate that again. And that's what I'm wanting here, is this little radius here. So if we reset that preview, I should now be able to get that more smooth rounded cut. Do you see that? You see how it's rounded off? Because I do have that straight down. That's part of the design, but that nice round, it wasn't making it so sharp there. My radius of my router bit, my 1/8 inch, was too big. So we've got that profile. Now I'll cut this out so you can actually see the trim. But let's go ahead and do the same thing with our rectangular piece. Let's drop this down a little bit, and we're going to create another molding tool path with this here, and we'll go ahead and move the arc because we're going to be using that in a moment too. Oops. Let's bring that down, and let me make this a little bit smaller so I can get all three pieces in here. Alright, so one more time, in that molding tool path, I've got my trail that my profile is going to follow, my molding, and I do want sharp corners on this one, like a mitered frame, and I can calculate that. And we can go ahead and preview, that tool path. So you can see that nice molded, and because of that radius of that bit, we've got that nice round over here. It's not so rigid and flat. and everything. So that's a nice profile. That would be a nice profile for like a raised panel door, you know, and things. And then once again, if we did it one more time with the arch in my profile. Now notice how this is arching inward here. I want to arch on the outside of this line. So if I simply reverse the direction, it will put it on the outside of my arc, this green node here. Okay, so we can go ahead and calculate that toolpath, and we can preview that toolpath. And of course it's cutting into my part a bit, so let's see if I can move that down a little bit so I'm not cutting into it. And let's open that back up and recalculate it. There we go. So if we reset all of these previews and preview all of them again, we've got our nice, you know, straight line, our frame that we're following, our rectangle, and we have our arch. So it doesn't matter what your shape is that you're following, the path that you're following with the molding toolpath, you just have to draw the profile out to scale, you know, and you do not use the bottom line of that if you start with a rectangle. And you want to make sure that your overall length and your overall height of this is what you're achieving and stuff. So let me know, Howard, if that helped answer your question at all. And we're going to go ahead and move on to the next question. Okay. Hopefully that helped a bit, Howard, and everything in there. All right, so we're going to go ahead. I'll leave these here in case we have to refer back to them. I'm going to go ahead and shut that layer off and add a new layer. And let's look at Peter here. Peter says, when should you use what bits? When the ball nose, when the end mill, when the upcut, when the downcut spiral. He's noticed that some bits are breaking. Is it, you know, the feed rate, too much depth at one time? Well, let's kind of talk about bit breakage. Bit breakage is the resistance of the movement of the machine and the router bit's ability to remove the material fast enough to keep up with that movement. If it cannot keep up with the movement, then ultimately the CNC is going to be pulling and pushing the bit faster than it can keep up, and it's going to start to flex, ultimately snapping and breaking the bit. So it's a combination of, one, the material, you know, that you're carving in, but the feed rate and the pass depth. Also the direction, you know. If you're cutting too much through your wood, let's say I have a piece of plywood, birch plywood, that I'm cutting through, 1/2 inch birch plywood, and I've got MDF as a waste board underneath that, and I'm running, I'm going 0.57 inches deep, so 70 thousandths of an inch into that MDF and all, or what have you. The resistance on the bit in the plywood and the resistance on the tip of the bit in the MDF is going to be two different resistances. You know, it might be cutting through that plywood very well, but because we're cutting deep through the plywood and then into the waste board, we got two different, you know, two different types of material, two different things, and that could cause stress on the bit, ultimately breaking it. Now, when do you use a, so you can kind of control that by your feed rate as well as your pass depth. Pass depth, typically 50% the diameter of the bit or less would be recommended. You know, the pass depth is 50% the diameter of the bit or less. Same thing with your step over, 50% of the diameter of the bit or less. But your feed rate is going to be dependent on the material that you're working in. For me, end mills, flat end mills, 1/8 inch, 16th inch, 1/4 inch, you know, they range, the feed rate ranges from 45 inches a minute to 75 inches a minute. and that range just depends on what material that we're carving. If I'm carving in pine, I'm more in the 60 to 70 inch a minute range. If I'm carving in walnut, I'm more in the 50 to 55 inch a minute range. If I'm carving in purple heart, I'm more in the 40 to 45 inch a minute range, because it's a much more dense material. So it really kind of, you would adjust accordingly. Now, I've seen people go through and do some test cuts with different types of materials and gauge, what speeds they can run in their pine, what speeds they can run in walnuts or maples and things. And then they actually set up the database, their tool database. They actually set up the database with different groups. So I would have, pine wood here for the group, and then I would have all of my bits underneath that group for the pine wood. And then if I had the walnut, I'd have all my bits that, and their appropriate feeds and speeds for that wood. Then walnut, and then those bits, same bits, but they would have different feed rates and plunge rates and all based on that wood material. And it's all based on the testing and things, so you can do that. You can actually break it up by category. So all you have to do is when you say, okay, I'm carving in pine today and I choose this, it already has the bit speeds and feeds for that tool, for that material. You can set up your tool database in any structure or format that you want. Now, when do you use a ball nose? When do you use an end mill? Well, that really kind of depends on the project. Typically, ball nose bits are reserved for 3D finish cutting. However, if you're doing a particular groove, let's say that I'm doing a cutting board and I want a juice groove in here, and I want that groove to have a nice rounded bottom instead of a square cut bottom, then I would use my 1/4 inch ball nose bit or my 1/8 ball nose, depending on how big I want my juice groove to be, of course. Typically I would use a core box bit for that, but your ball nose gives it that nice rounded bottom and everything. So you're either typically using the ball nose bit for your 3D finish cuts, that's your detail bit, or you're using it because that particular design or part that you're cutting calls for kind of a rounded bottom, not a flat bottom, a little bit of a cove or something to it, that rounded bottom and all, and everything. So if my juice groove, if I was looking straight on in a juice groove here, however wide and deep it is, and it called for that juice groove to have a rounded bottom, then I would use my ball nose bit for that. And I would use the appropriately sized bit for my juice groove. That's why typically a core box bit, that has, 1/4 inch, 3/8, 1/2 inch, diameter. Typically that's a good one. But you can use your ball nose bit for that. Now your end mills, your flat bits, those are when they're your rough cut bits, for your 3D finish cuts. They are the workhorses. They're hogging out all the waste material when you're doing a 3D rough cut. But for regular carving, they're your profile cuts, cutting out a piece or shape and everything. Doing pocket cuts, if I'm doing a pocket or a groove or a rabbit or a dado, it's a part where I need a square bottom in my groove. When I'm cutting this out and all, I need that square, nice straight edge, square bottom and everything when I'm cutting out that groove. That's my end mills, So if that project calls for that type of cut, then that's the bit, that's the tool path and the bit that I'm going to calculate for is that tool, V-bits or V-carving, anything that you want, like your letters, your pictures and things, you want to V-carve, that's when you would use your V-bits. Round over bits when you need a round over and everything, so there's specific tasks for those specific bits, and what bit to use. There's no magic thing saying, hey, use this bit. You have to know what you're designing and what the end result you want. If you want a round bottom, use your ball nose bit. If you want a square bottom, use your end mill. If it's a 3D rough cut, that's your end mill. If it's a 3D finish cut, that's your ball nose, the detail bit. You know, if it's a V cut, then use your V bit. On and on and on. So hopefully, Peter, that gave you a little bit of a guideline. Hopefully that gave you a little bit of a guideline as to what bits for what projects. All right. All right. So Glenn Jones, can you show us how to use the Vector Validator tool and the best way to close the vectors when you have open vectors? All right. So the Vector Validator tool, I'm going to actually trace an image for this demonstration. So let's grab this guy here. Oh, he's going to be a little one. Let's kind of zoom into him. All right, let's trace him out. Okay. Now, I'm going to turn off that layer and we're going to unclose that. Now, if we look at this tracing, if we zoom in, you see these figure eights. These are pixels, okay? These are pixels. These figure eights and all, and they're considered overlapping lines. So if we look, you know, this is just a square pixel. We want to get rid of all these little pixels and trash, but if we need to, we can use the Vector Validator that will help us determine the trouble issues of our vectors. It'll help kind of point those issues out to us. Now, there is one tool or one trouble area that the Vector Validator will actually clean up for us, and that's our zero length spans. So a zero length span is a set of two nodes that are essentially kind of on top of each other, and there is no span between them. They're actually so close. There's no, you know, like if I had these two, let's say that these were two nodes here. Let's actually make this one a little square so it's a node. And we had our line, our span in between those two nodes, those 2 points and everything. If these two nodes were close together, you know, or touching or on top of each other, there would be no line there. There'd be no span. So a zero length span is where those nodes are coming together. There's no line, and we want to clean those up. So the Vector Validator tool, if we were to select this line here, let's make him a little bit bigger. Let's go ahead and scale him up and everything, and get him in the middle of the screen. If we scan or search the issues, 46. All right. So now we have zero length spans, which is good, right? We have none of those, so we don't have to use our fixed zero length span tool down here. But we have 7 overlaps and 57 intersections. Now the overlaps are identified to us by this box with an equal sign. And the intersections, where lines are intersecting, the points of intersection of overlaps and things, they are identified to us by the box with a plus sign. Okay, kind of this crosshair, this 4-point box with a plus sign. The 2-point box with the equal sign is the overlap. So let's kind of zoom in here. And this is one of those figure 8 parts. All right. And at that intersection of those figure 8 pixelated part, we have those 1, 2, 3, 4 intersections, right? If I close this tool, you can see those intersections. You can physically see where those lines are overlapping. So all right, let me know when we're back. Okay, that was my fault. All right, there was something when I was calculating that vector, it threw out everything. All right, so let's kind of talk about this again. So I don't believe it might have went into black screen. I don't know if you saw me give the definition of a zero-length span, but we'll do it again. So a zero-length span. Let's pretend that we have two nodes here. Gonna make them nodes, and we have the span between two nodes, our vector line. That's the vector is the point between the span between two nodes. Well, if my if my nodes are close together or overlapping and everything, well, there's no span in between them. There, the start and end point are basically there's nothing there. So we want to get rid of those. We don't need them. And so in the Vector Validator tool, we have the Fix Zero Length Span tool. So that will actually get rid of all those overlapping nodes that have no span line between them. Okay. Now, as far as if we were to search the selected object here, so it'll buffer, give it a minute. And Ron, I'm answering the questions in order, so I will get to yours. So bear with me. All right. So now, if we zoom into this, the buffering should be done by now. We look over here in our tool. We have 7 overlaps, and they're identified by this 2-point square with an equal sign. And then we have intersections where our overlaps intersect. And that's identified by this 4-point box with a plus sign. And so if we came in to this figure 8 here, we can see where those lines intersect each other. We have 1, 2, 3, 4 intersections. This is a potential issue. So the validator is pointing all of these issues out to us. Now, this validator is only here to point us in the right direction. It's up to us to go through and clean the things up. So if we were to close this tool, we can now go through and start to eliminate. Let's ungroup everything. We can ungroup things, and we can start to go through and eliminate the trouble issues, these figure 8s and all, and we can go through and start cleaning things up, getting rid of all these little pixels and noise and things and all. And so let's get rid of this one. That's the one I showed you in the lesson. Let's get rid of a couple of these. All of these are pixels, they're just trash, and I'm just selecting and deleting. All right. Let's kind of go through. I'm just going to go through and start grabbing all this trash. Oops, that's not trash. Let's see here, right here in the nose area. And notice I'm just dragging a box. I'm using my left mouse button. I'm dragging a box, selecting these. If you drag from left to right, if the item is not 100% in the box, it's not going to select it. So you don't have to worry about going over other lines. If it's not 100% in there, it's not going to select it. So what I'm doing is I'm making sure all the pixels and stuff that I want to remove are 100% in the box, and I'm cleaning them up. That way, I'm just cleaning things up. All right, so let's take a quick scan here. Now let's use the Vector Validator tool again. Let's select this and use our Vector Validator tool again. It may buffer, so bear with it while it buffers, while it's searching these things. All right, So out of all those 57 and 20, whatever it was, oops, black screen. I'm aware of that when I saw that one. Give it a second to come back. It'll be back. There we go. Alright, so of that, after cleaning up all of those pixels and overlaps and everything, I still have 3 overlaps. Now the overlap are where 2 vectors are on top of each other. They're overlapping. And generally, if we look at this, generally the overlap is at the starting and ending point of the vector. So if I went into, I'm focusing on this overlap right here on this end. If I go into node editing and I click on this point, okay, right in here, I've got, let's get rid of that and let's get out of node editing for a minute. I've got what is considered an overlap here where my curve is going around, but there's not actually anything there, and there's nothing I need to do to it. If I wanted to, I could, let's go back into node editing with it. I could cut the vector there, kind of pull this away. And see what my issue is. I don't really think I have one. If I grab this again, I'm going to rejoin that up by bringing the 2 endpoints back together. And that overlap there is not going to cause me an issue, so I'm not worried about that one. But let's go ahead and research it again. Just that one vector. And so now I have one intersection, so I turn the overlap into an intersection. And that's where the overlap, where the lines were going, now they're crossing each other. So let's go back and let's see if I can zoom in tight enough to get rid of the intersection. And no, I can't. There's nothing I can do there. So it's very clean. It's just pointing out that that's a potential issue, but it's not an issue. There's nothing I can do with that. There's no trimming to be done. There's no nothing. So we'll go ahead and we'll ignore that one because there's nothing you can do with it. So I'm down to 3. I'm down to 3 overlaps and intersections, and they're going to be just points that they just can't be cleaned up. There's nothing to do with them. There's nothing I can go back and do. So now, but I've gotten rid of 98%, 97% of my issues with the Vector Validator tool. Now I can come in and do my V carving, whatever it may be. And I can reset my preview, and I can carve my, line, whatever it may be. All right, so the Vector Validator tool just helps point us in the right direction. It helps point us in the right direction where our intersections are, where our overlaps are, and where our zero length spans. It's up to us to go and clean them up. The zero length spans are the only ones that we can push a button for, and Vetrix removes them. The intersection and overlaps we have to go through and clean up. Now we also have to look at those and see if it's actually a valid intersection or overlap that we can actually do something about. Okay, so I hope that answers your question. All right, now let's go back up and all right, Ron. Ron, buddy, stand by a minute. Glenn's question is there. Howard, Debbie. Ron, the question where you asked me, Lainey, did you see my question concerning the difference in machining? Was that question in the chat group? Because I went back to the top and looked down through the names, and this is the first time I've seen your post, a post with your name, and it was asking me if I saw your question. So I don't know if the question made it in there or not, but I do not see it. Could you please find your question and repaste it, copy and repaste it for me to answer, and when you do that, I will go back and answer it. I'll answer that now or next. So Ron, find that question about the machining, the difference in machining, and then we'll come back and answer that. Now, Glenn's it was a two-part question. So with Glenn, it was the vector validator tool, and then the best ways to close vectors that you have open. Okay, so let's first of all talk about what an open vector is. Let's go ahead and I'm going to create a new layer. Turn off this line here in case we have to refer back to it. And let's go ahead and just start off with a very simple rectangle here. And if I cut this right here on this corner, cut it here, cut it here, I have now taken one closed vector that starts and ends on itself and turned it into two open vectors. I have the left side, top and bottom of the rectangle, and then my second vector is the right side here. Okay, so now we have a join tool, an automatic join tool that will let us it will look at anything that falls within our tolerance, and by default our tolerance is generally 0.004 here. And so any gap that falls within this distance, then it will go through and close, right? So I have two open vectors. If I join them, I'll have one closed. Okay? But what if these lines were a little bit further apart? Okay? I have two open vectors. It won't let me join them because that gap here doesn't fall within my tolerance. So what if I change my tolerance? Let's make this 1/4 of an inch. Okay, that gap fits within my 1/4 of an inch tolerance. Now I have two open and I have one that I can close. I can go ahead and join them, and notice how it pulled that rectangle or that line back in and closed it to that rectangle. Okay, so join them back together. So I'm going to undo that. And so what are other options if we can't join, and we should be able to change our tolerance to join something. But if we can't join, we can join the objects with a straight line. We can join them with a curve. We can join them by bringing the end points to a common point of intersection. So if I join this rectangle with a straight line, let's get off of, let me move this over to the left here so we're not on these center lines so you can actually see. If I join these with a straight line, I have to actually click the tool twice because there's two openings down here. So if I join with a straight line once, twice, it's going to close that off. Let me undo that. I have the option of joining with a smooth curve, and let's kind of come up here, and if I join with a smooth curve, it's going to create a curve to close it off. Okay, not a straight line, a curve, a Bezier curve. If I undo that, What if I use the join or close? These are all join and close tools. Join and close by moving the endpoints to a common point. So if I select this, it's going to move those endpoints to a common point, and it's going to close them off. Here's a better demonstration of that. Let's actually take this line out of the equation. My two endpoints on this rectangle here, the top and the bottom, if I join them by bringing them to a common point of intersection, what's it going to do? It's going to bring them to the center, right, and close them off that way. So there are essentially 4 ways of joining and closing a vector: by actually adding to the vector with a straight line, a curve, or by moving, the endpoints to a common point of intersection. Or we can join by just closing up the vector. And in order for us to be able to join, our lines or our tolerance has to be, our gap has to be within our tolerance. Now notice I moved this line away even further now, right? And so now it does not fall within the 1/4 inch tolerance, so therefore it's not going to let me join. So let's bring that up a little bit. Okay, 0.375. Now that gap falls within that tolerance. Now I can join, and it's going to pull that vector back together. All right, so that's the join and close tools. Okay. All right. Is there a chart for feeds and speeds for specific words? Well, a while back ago I used to say no. No, there is not. No, there's not a magic chart for speeds and feeds. But a little while back ago, someone pointed me to and said, yes, there actually is now. It's a calculator, a speed and feed calculator for woodworking, which has not existed as far as I know. So so I researched. They told me what it was, and I looked it up, and it's not free. So I believe that tool woodworking CNC feed and speed calculator. I can't even remember the name of the tool because once I saw how much it cost, I wasn't even interested in it. I believe it's in the CNC cookbook. Definitive Guide to Feeds and Speeds for Wood. And the G-Wizard golly. G-Wizard Speed and Feed Calculator. Now, when calculating feeds and speeds for wood, we generally look at 4 families. You can see them in the G-Code Wizard. So they look at hardwood, MDF, plywood, and softwood. So they really don't go into species. Okay? They really don't go into species. It's a speed and feed calculator for hardwood, softwood, plywood, MDF. Right? And just 4 types of wood. Why not more? Right? That's the question asked. To access a full variety of woods under each family, use the More button in the G-Wizard, and they break it down. We don't have a lot more categories, but they have some in the More, and therefore if we look at the speed and feed calculator for CNC routers, okay, you got a free trials. Start now, it's free, and it's only free for a little bit. and then there's a fee. And, you know, so if you would like to give it a try, I do not know if they have a trial period where you can cancel without being charged. I didn't go any further than the start now it's free when it starts talking about fees and things. I didn't go into it any further than that. But they say here that they looked at 250 different tooling categories. They've considered over 16 different variables. They looked over, they've worked with 100,000 or more CNCers and everything. And this speed and feed calculator is generally mostly a lot of metals and things, but they do have some categories for wood, and you can give it a try. I'm not going to recommend it one way or another. That's going to be up to you whether you want to spend the money on it or not. I have not seen what it can do, what it's capable with. Hell, I can cut a piece of plywood, a piece of hardwood, a piece of softwood, and a piece of MDF, and I can practice and see what speeds and feeds I want to run my machine at. If I'm going to use a speed and feed calculator, I'm wanting to know what speed to cut in hardwood, Purple Heart, IPE, hard maple, soft maple. I want it broken down for me, if I'm going to spend money. And so you'll have to figure that one out on your own. But it's in the CNC cookbook. It's called G Wizard. Okay? All right, Debbie. Hopefully that answered your question. All right. Let's see here. Debbie asked a second question. Is there a file for the wasteboard that we collaborated on in the class group? No, not yet, because we never finished that project, Debbie. We kind of got dropped into the back burner, and we never finished it up. So we need to actually revisit that project. And now that we're structuring kind of the one class setup, it will give me a chance, because we had a lot of things going on with that cutting board. Overlapping pieces so we can add to it. We had some T-tracks in there, grooves and things, and then we had some dog holes and stuff. So it'll actually give me a chance to actually make this piece and test it thoroughly, just to make sure that all the pieces fit together, T-tracks fit in it, and all that stuff, how well it clamps and all, before we put out a file. But right now, currently, there is no file for that one. We never finished it. So we got to go through and finish it, but at the same time, we also need to kind of test it, before we put the files out there. Test it. We can collaborate on it again, and we can finish it up, but we gotta wrap it up and tie it up and all. But we gotta actually test it and all before we put the files out there to make it. All right. So Joe CV. Can the tool database be copied and pasted or imported from one computer to another? Absolutely it can. And you want to do that. You want your tool databases to be the same on each computer. So in the tool database, you would generally come all the way up to the top and select on your Imperial tools. That'll, any category that falls under the Imperial tools, it will copy. And you want to export them out to wherever you would save them. And for me, I would highly recommend saving that in this PC folder, the C drive, users, public documents, Vectric files folder that's already there for you. And I've got a folder in here, router bits and tool profiles, that I actually created a folder for. And that's where I would, export that tool database. So this would be my Imperial tools database, and we would save that out. Now you could also save it on a flash drive and import it in. But when you bring it over to the other computer, put it in the C drive, public documents, Vectric files folder, and then when you come into your Vectric software, import that folder from the Vectric files off your public documents, publics in that Vectric file. Import that file in, and it'll bring it in. You know, if you're replacing, you know, let's say your tool database, you want it to be exactly the same, then delete, you know, delete your category, delete it, get rid of all of these, and then bring in that tool database, that fresh, clean tool database that is the same as the other file, you know, the other computer and all. That way you don't have duplicates, you know, because if I paste it in, if I import it in Imperial Tools right now, it would import it in with right on top of this one, and now I'd have two. Okay, I don't need two. I only need one Imperial Tools category with all my router bits and everything in there. And so, but yes, it absolutely can be brought in. All right. Okay, so Ron asked the question, Laney, did you see my question concerning the differences in estimating machining times in the VCarve Pro and the USB CNC controller? VCarve will list the times at 4 hours, but CNC USB is much less. Okay, well, this is in the CNC or in the Vectric software, our clock, our estimated time. Okay, we have to put in our rapid rate and our scale factor. So if I'm working with a 2440 machine, my rapid rate for the 2440 is 150 inches a minute. So you want it to say inches a minute, 150 inches a minute. Now the scale factor is this. Okay? If I have a 1, generally it's a 1.3 scale factor as a default. But let's say I have a 1 scale factor. That means on my swept profile here, the Vectric software says 32 minutes and the CNC USB controller software says 32 minutes. Okay, and it runs in 32 minutes. All right. If it tells me in the Vectric software that it's 32 minutes, but it takes me an hour and 4 minutes on the machine to run, that is a scale factor of 2. Okay? If it takes me 2 hours and 10 minutes, it's a scale factor of 4. You know what I mean? So you have to adjust the scale factors so they match. All right? This is an estimated time. The Vectric software is going to calculate a time based on the toolpath, the rapid rate, and it's going to use a algorithm for the scale factor because it doesn't know what the acceleration and deceleration is of the CNC machine when it's turning corners and it's slowing down and it's speeding up, what its ramping, you know, speeds are and its deceleration speeds and things. It doesn't know all of those variables and stuff, so it's got to take in a scale factor into its algorithm, and so we need that scale factor to be what it is. And generally, it's a 1.3 scale factor. If that's not correct, if you're getting variation where Vectric is saying this, but it's actually taking this to run, then adjust your scale factor accordingly. Okay? Now, if you're running the mini carver, the rapid rate is 125, and the scale factor is 1.3, or adjust your scale factor so that it matches and it's appropriate with the actual machine time. So if the job tells you it's going to take you 42 minutes and it takes you 42 minutes, then your scale factor of 1.3 is correct. If it takes 20 minutes to run, then your scale factor is wrong. You know, you need to back it down. It might even be a 0.9 scale factor or you know, whatever it may be. Now, it doesn't do decimals. Notice that my time, if I go 0.75, you know, it's not going to adjust me any lower than that. So it's either 1, 1, 3, 2, 4. We got to have at least 100%, right? If I go a 50% scale factor, you know, it's not changing it. If I go 1.5, then it's going to change it, you know, so on and so forth. So you need to adjust the scale factor accordingly. So Ron, hopefully that answers your question. So they match. The Vectric is going to do its best based on its algorithm to calculate or estimate the machining time. But it's not going to be, you know, an exact science because it doesn't know. There's so many different CNC machines out there. It doesn't know the acceleration and deceleration, so it's going to use our scale factor in there. All right, so job setup sheets. So I do not believe that. I think now maybe the Vectric desktop, the version 9, might have job setup sheets. I don't think it does, but but I'm assuming Howard, you're talking about the job sheet here. So if I were to create a job sheet, this summary, let me put it. Put in Kevin's sign, and let me go open that folder up. Okay, so the job summary sheet. Now, this is showing in a window browser. Okay, it's showing in a window browser, but it is not an online file. If you look at the root directory, it's coming and reading off of your computer. It's just using the browser to be able to create the different graphics and things. It's just using the browser. You do not have to be connected to the internet to see your job setup sheet. Now, as far as being able to print it, download it, what have you, we can come in and we can right click and we can print the job setup sheet if we need to. Let it load the preview. You know, we can print it. Now, it will not print in all the little cute little graphics and things that are you know, in there, the little square blocks and stuff. It will not print those. It's just going to print the 2D. It's going to break it down into basically a 2D, a job summary sheet. You can, if we close this, cancel the print, you can, I believe you can download it as well. I think it's just for printing or viewing, but bear with me a second. If I go into save as, I can save it and I can print it as a PDF. Change from my printer to a PDF document, and I can download and save that document for whatever reason. It's already saved. I don't know why I would want to save it again, but I would generally just want to print it because we're not having to be connected to the internet to view it. But if we want to take it to the workbench with us or something, then we can just print it, or we can save it as a PDF and then print that. I mean, that's an arbitrary step, but you know. So I hope that answers your question, Howard, about the job setup sheets. Do you have to download it? No. And Howard, if it's not in your list, when you say your list, is the job setup sheet in here. And if you have Vectric V Carve Desktop, you will not have the ability to create a job setup sheet. If you have Vectric V Carve Desktop, you will not have the ability to create a job sheet. That's a VCarve Pro or Aspire feature. I do not believe Desktop 9. Let me open up Desktop 9. I do not believe that function. Alright, I haven't even licensed my desktop yet. I do not believe it's a function in even version 9. I think it's just a Pro or Aspire feature. So if you don't see it in your over there on your tools, or another place that you would see it is, let me open this up, is under I know it's in here. Yeah, right here. Under Toolpath, if you don't see the option for Create Job Sheet, you won't have that ability. Okay, good. You have Pro. All right, wonderful. So, did you find it? It's either in the Toolpath or it's in the Toolpath side. Now, if you won't see it, Howard. You won't see it on the right side in the Toolpath unless you have Vectric 9. In Vectric 9, if you have 8 or 8.5. Then you will see the job sheet up here under the menu Toolpath Create Job Sheet. If you have 9, they actually put an icon over here next to the Save tool for creating a job sheet. All right. All right, ladies and gentlemen, any questions? Any other questions? You know? All right, so Howard, if you don't see it in 9015 over here, right next to the Save Toolpath, let's see here. Let's go to Edit, Options, and let's see here. Show Toolpath Operations Preview, Open Auto, Select Sheet when Edit Toolpath, Add Duplicate Toolpath to the end, Maximize the Toolpath stock. Okay, I don't see an option for like turning it on or off. So what you may want to do is go into your user portal and maybe reinstall it if you don't see it over here. Reinstall that update and all. All right. So, any other questions, ladies and gentlemen? Any other questions? And have you had time to think about the classes, the class schedule? Do you surface a... Oh, wait, hold on. We got another question there. Debbie, do you surface new MDF wasteboard? If so, what bit do you use? Yes, you do. See, MDF is absolutely known for being flat material, right? When it comes from the manufacturer, I mean, it's known for being flat. But we don't know how long it's been sitting over the shelf at Lowe's or Home Depot and things, and if they have proper supports and stuff and all that, you know, to make it flat if there's a little warp or curve. Hell, it could be a bad day at the factory, and at that 0.75, you know, might be a little bit off, a little bit heavy on the glue, whatever the case may be. You never know. So we want to eliminate those unknowns by surfacing our waste board. Why would we throw just an MDF board on the table and not surface it to make it absolute parallel to our router bit? You know, we're kind of setting ourselves up for failure. We want to surface it because we never take anything for granted, right? We never take anything for granted. And so what bit do you use? Well, Whiteside has a very nice surfacing bit. We have surfacing bits available. We have an Amana. So let's jump on line here. And let's go to amanatool.com. And our tool, bear with me a second, a website that we can drop ship to any customer, but let's see here, digital wood carver right there. All right, RC 2248, RC 2248. RC 2248. Hello. There we go. So this is a 1.5 inch diameter, 1/4 inch shank router bit replaced with blades. You know, we have this bit. I believe this bit is $135 that we have it for. So that's one option. Right. We also have one with a 1/2 inch shank, but it's in the $300 range. Let's look at Whiteside. Let's look at Whiteside. Whiteside surface planing bit. This is available. You'd have to order this off of Amazon and things. But you know, this is the Whiteside 6220 surfacing bit. I believe this is a 1/4 inch shank for this cutter, right? Magnate has their surfacing bit, magnate.net, the 2715, right? So there's a lot of different surfacing bits, but Whiteside, like I said, 6220, their surfacing bit. Magnate has their continuous surfacing bit. We have ours, you know, from Amana Tool, and all. So you know, they're just all kinds of surfacing bits, but you can use that. You can use you know, a bowl bit. You know, like if you have a bowl and tray bit, you can use that bowl and tray bit. And stuff, but that's what you would generally use for surface planing your MDF. I mean, hell, you could do it with a 1/4 inch bit, but boy, would that take forever and not really the best way to go. You want a nice solid surface area, and you're skimming off the top, you know, few thousandths of an inch. You do not want to be taking off 1/4 of an inch, this and that. I mean, that's a waste of MDF. So you just want to skim it off. All you're doing is leveling that out, or paralleling it out. Shouldn't say the word level. Paralleling it out to the router. You're making it surface parallel. When adding the end mill, the surface planing bit to your tool database, it's an end mill. Okay. Just you would put it in just like an end mill, and you would have your, let's say that this is a 1 1/4 inch diameter, you know, surface bit. For your removal, we're going to go a 1/16 of an inch. past depth on this because we're only taking usually 20, 30 thousandths of it off at a time, but we don't want to be too aggressive with the bit. We want to step over 33 1/3% of that bit. And for the feed rate, now here for the RPMs for you guys and girls who have spindles, the larger the diameter, and for your routers too now, the larger the diameter of the bit, the slower the RPMs. So to run this, you want to be about 16 to 18,000 RPMs. Now, if we go back online here and we look at the specs of the bit, let's just go ahead and look at the, we'll go to Amazon for this white side bit here. And let's see down in the specs if it gives us any kind of information. No. All right, so let's get out of there. Let's actually go to whiteside.com. Well, let's check out Woodcraft. Let's see if Woodcraft. Let's see if they put the RPM specs in there. Hopefully they did. No, come on now, Woodcraft. More details. Let's see here. No. All right. But generally, you're about 16 to 18,000 max RPMs, which if you have a router, your Hitachi, that's between about the 4 and the 5 dial, 4 and 5 on that dial. If you have a spindle, you actually program that in, in here in the RPMs. Now, as far as the feed rate, we can go high with this. We want it skimming across. So we're only taking a few thousandths of an inch at a time. So we're going to be probably maybe 75. Oops, wrong place to type that in. 0.65. We're going to probably be about 75, 80 inches a minute. Plunge rate 15. The plunge rate is actually going to be slower. This is, when it's plunging down, we've got a big surface area to cover. Most wear and tear on the bit is during the plunge. So we'll go with a 10 of a plunge, maybe a 15. Yeah, we'll go 15. But 75, 80, you can run faster speeds with that. Conservative speeds would be 55 to 60 inches a minute. But a maximum, a cap, would be about 90 inches a minute, 85, 90 inches a minute. But so you could kind of break it around, not break it when I mean break, I'm not breaking it, but you can probably kind of break in about 75 inches a minute running it and stuff. It's just, again, we're only taking a few thousandths of an inch off. Now, if you're being aggressive with your surface bit, taking, a 1/4 inch at a time for whatever reason, then you're going to slow that down dramatically. And you're going to take small bites, right? Okay? All right. But it's added as an end mill. An end mill. It's added as an end mill. Right, Peter, that's just the same way, just like if you were running a board through a drum sander. If you take a chalk or a pencil, no markers and things, that shit bleeds into the MDF now. But, a pencil and things, you can mark across your wasteboard, some wiggly lines and stuff. And that way when you're, if I was running through a drum sander, then I can see as those lines start to disappear, what areas are actually making contact with that drum sander, right? So we can actually, we can put a pencil mark in there and we can see what areas are getting milled off and stuff. And if I ran through my whole surface board and there was still some pencil mark, that would mean that part is lower, right? That's the lowest part of my wasteboard, and so the bit just glided right over it, didn't even cut it. Therefore, that means I should actually be touching off over there on that low spot. We want to find the lowest spot, if there is one, right? We want to find that lowest spot if there is one, and we want to zero out from there and then mill off our surface, and we want to level everything out to that. You know what I mean? So, using a pencil, or something, a piece of chalk or something, is a great way to do that. And that's a good tip, Peter. Thanks for sharing. All right. Any other questions? But yes, the short answer to that is yes, we should always surface our wasteboard. When we put a new wasteboard on, this should be the first thing we do to it is surface it. And yes, Peter, you can. When you're doing things, let's say that we're doing a two-sided project. Knife handles, we talked about, we've never really made knife handles, but let's talk about that. I would take my blank piece of wood. Let's say I'm cutting a set of knife handles out of a 8x8 piece of wood by 3/4 inch thick or 1 inch thick, whatever. I would put that on my table, and I would surface off the top side of it. I would then flip that board completely over, and I would surface off the second side, and that second side surfacing is actually going to be taking that piece down to its final, thickness before the carving, So if I had an oversized piece, a piece of rough sawn material, whatever, 1 inch thick, and my project was designed for a 3/4 inch piece, then I would skim off, I would surface plane that first part off the top, I would flip it over, and then I would surface off the other side down to that 3/4 inch. I would remove that 1/4 inch of material, stepping down, making sure that both sides are parallel to one another and to my machine. And then my surface board, I should have already had if I have a surface board on the table, it should already be surface planed. But let's say I'm using a sacrificial waste board on top of my waste board for whatever reason. Then I would, I'd put that, let's say I have another little 10 by 10 piece of MDF that I'm throwing up because I'm going to be cutting into all the way through these knife handles. I don't want to cut into my big waste board. I'm going to use a sacrificial board on top of my sacrificial board. Well, then when I put that MDF piece, that 10 by 10 inch MDF on the table, I would surface plane it. I would skim off a few thousandths of an inch to level it out. I would never take for granted that it's completely level. Now, I only have to do one side of it on that one. I only have to do one side because when I mill it off, it's gonna level or parallel that side out to my router, And then now with that side planed, then now I can go ahead and clamp my workpiece to it, and do my carving. I'm setting myself up for the biggest chance of success. So we surface plane, level things out to our machine and stuff. All right. Do you recommend scribing an X and Y line in the wasteboard with the router to help align your work? Well, yeah, absolutely. That depends on. Now, if I'm going to be, I wouldn't just do one line. I would actually have a grid of lines. Maybe space them, I don't know, 1.5 inches apart, 2 inches apart, something like that. And I'd have a grid because I might not want to have my piece of material always in the same spot, on that X and Y line. I might have small pieces that I'm clamping towards the front middle of the table. I might have a big piece that's going to be down towards, the Y minus and everything. I might have a square piece that I want, kind of in the middle. And so I want to have some choices, some scribed lines to be able to square up my piece no matter where I am on that wasteboard. So personally, I'd recommend a grid of some sort. Maybe even if it's just a 24 inch by 24 inch grid or 12 by 12, just something to where I can have two lines in various positions to work off of. So yeah, I would definitely recommend that. It's the best way to make sure you're getting square. We just went through all the trouble of surfacing off the board to make it parallel, only to just eyeball the squareness of the board going on the table to screw it up. If we scribe it with our CNC machine, and that waste board is fixed onto that machine, not moving, then my lines are my lines. That's the path my machine's running on, the X and Y. You know what I mean? So absolutely, I would recommend that. All right, Howard, here is your thoughts on the new schedule. Being a new guy to this, I'm all for it. Good to hear that. The reason is he can see what the machine can do and learn more on how to go from the plan to finish. Absolutely. And that's exactly the key, is we're going from plan to finish. You know, whether I started this project off in SketchUp and kind of just laid it out to see what it would look like, you know, and then how did I take that and bring it into the Vetrix software and draw it out with all the joinery and the grooves, whatever it may be. And then when I'm at the table, what was my clamping methods and stuff, and then ultimately what was the finished part, what did it look like, right? You know, so start to finish, and it's a much more it's a much better lesson. It's a much better lesson because you get all the aspects of it, not just a small piece, right? These small pieces, how to draw in Vectric. Well, I think we all, even some of the new guys and girls, know how to draw in Vectric by now, right? Whether they know how to do it right or what tool to use, you know that. But we know how to use the Vectric. We know how to use the same. But what do we do? What do we do out at the table? You know, how do we clamp it? What are our options? You know, how did we machine it? Did we surface off one of the sides before we started machining it? Did we do this? Did we do that? All of those things could be answered with this new lineup. You know, this new way of instructing, and I think it's just going to make for an awesome tutorial video, set of plans, you know, everything. Right. So I thank you guys for spouting on that. Let's see here. All right. Okay, so I don't see any other questions. So we're going to go ahead. It's 9:39. We're at only 9 minutes over schedule. I wanted to go to 9:30, so hey, that's not bad, right? We answered some questions, right? It was kind of a little bit of a productive class. We answered some questions and talked about a couple of tools, the create job sheet, the molding toolpath, different things, you know, right? So I want to say something to you guys and girls. I'm in the process for those individuals that have the Vectric VCard desktop software and they don't have access to gadgets and things. You know, I've got different little programs for different G-code generators, for surfacing G-code generators, for calculators, you know, and things like that. Well, I'm working on a G-code generator for keyhole G-code generator. And basically, if I can kind of give a glimpse in it. So imagine that we don't have access to the keyhole gadget, right? We don't have access to it because we have Vectric desktop or something. So we have to kind of figure out how to do a toolpath in here without it. So let's say that I want my keyhole toolpath to be kind of in the center of my project board. Maybe I want just one, right? And I want it to, oops, sorry, didn't mean to be in the circle tool again. And I want it to come in, and I want it to, that keyhole bit to plunge in, cut, come back, and come back out the same hole. So how would we do that? Well, in the Vetrix software, if you do not have the keyhole toolpath, we would actually draw a rectangle. The length of the rectangle, or height should I say, is going to be how tall you want or how long you want the path to be. So in this case I want a 1-inch keyhole from the entry hole. And then the width is only going to be about 1/1000 of an inch. 1/1000 of an inch. Okay? Super small. Now, I want to center that up on my board, so let me align that to center. And now if we zoom in, the one thing that I need is I have my 1 inch, right? I want my bit to plunge in, I want it to go up 1 inch. So I want to bring this, I'm going to use my up arrow key, I want to bring it to the top of my circle because I'm going to remove the circle. But let's close that. Now if I zoom into my rectangle, I want that bottom line gone. Node editing. Delete that span. Okay. This gives me a start point, and 1/1000th of an inch is absolutely insignificant. So my keyhole bit is going to come in at this green node. Let's kind of move this up. Let's get this whole thing on the board. Bear with me a second. Let me center myself up. I'm going to shorten it up from 1 inch. Oh. Bear with me a second. Let me go in and I'm in node editing. That's why it's not moving. Let me shorten this up for a minute just for demonstration purposes, because I want it on the full screen so you can see it. Alright, so we're going to get rid of that bottom span. Let's zoom in so we can see the bottom span because it's solely 1/1000th apart. We're going to delete that. It's going to be a profile cut. The bit's going to come in, it's going to plunge down. It's going to cut along that path. It's going to come over that 1/1000th of an inch, which is barely a movement, and it's going to come back out that same hole, on this node here. So it'd be a profile cut on the line. Okay? Profile cut on the line. The depth of cut is going to be the thickness of that head of that cutter plus some. So let's say I have a 3/16 inch head on my keyhole bit, and then the neck, of course, comes up and everything. Then I want to at least be at a 1/4 inch depth of cut. So I have that 1/16 of an inch of material, for this that holds the screw head and all when you're hanging it on a wall. But we would calculate that tool path, and we come over. Let me control this down so you can see. But you can see that it's going in, coming up, coming back, and then coming back out that same hole. So we draw a very small rectangle, 0.001 inches wide by however long you want your keyhole bit to be. Remove the bottom span, you do a profile cut. Okay, that's how you would do it in the Vectric if you did not have the gadget, the keyhole gadget. That's how you would create your keyhole. But I'm coming up with just a very simple G-code generator that will allow you, it kind of works off center right now. From center, it will allow you to identify where your keyhole is going to go, how long it's going to be, how deep you want it to be, and everything. And it will actually create the G-code for your keyhole bit. Okay? It's going to be part of the Digital Woodcarver Companion software package. It's a very simple little G-code generator for keyhole bits for those that do not have access to gadgets. And I'll be releasing a beta version of that shortly for you guys to test and everything. And just wanted to let you know. So that's something new that I'm coming out with. All right. Okay. You're very welcome for everything, Debbie and everybody. I want to thank you guys. Y'all have a great night. Have a wonderful night. And until next time, I'll see you soon. Oh, before we leave, how was, other than the little bit of blurriness on the screen, were you guys still able to follow along? Were you able to kind of make out things? Was the quality okay. I know there was some buffering and some black screen when I was calculating that lion's head. That's going to kind of happen from time to time because it uses a lot of CPU usage when it's calculating and stuff. But overall, was it a little bit better viewing experience with less buffering? There was some minor, but I mean, it wasn't like constantly. Were you able to kind of follow the mouse and know where I'm at, even though the icons aren't crystal clear? Is this setting okay for now? Or do you want me to keep searching? It's about the best setting I've come up with. So, yes, right. There was occasional buffering when I was working with the lion's head and things like that. So, and you know, and that'll happen. It's going to be based on your internet's upload rate, my internet's, or your internet's download rate. Sorry, my internet's upload rate, and then the bit rate of the actual video streaming up there and everything. So, based on my upload rate and my bit rate, my settings now, hopefully it makes it a little bit more of a okay. I will see what I can do about getting that clearer picture. It's going to be a higher buffer rate. Now, I was working with a 480p, 470. So I believe I'm going to try maybe the 720 next time, and you know, see how that does. And I'm going to try to find that sweet spot. All right, ladies and gentlemen, y'all have a wonderful night. And until next time, I will see you soon. Laney out.